Alrighty, hello. We're starting exercise 8D here. So exercise 8D is just the different types of paths or walks we can take. I think we'll call them paths just because walk and trail. Oh, there's path as well. So everything is related to this picture, and I would recommend you trace it along it as I work over it as well. Now let's have a look. The definition of a walk is a sequence of edges linking successive vertices that connect two different vertices in a graph. What that means is that from here to here can be considered a walk, so G to P, or I can go from G to P to F, that's considered a walk. So G to P, to F, that's considered a walk. Or, I know I've been starting at G, I can start somewhere else. I can go from F to G2 to P back to F. That counts as a walk as well. Okay. So just put a few examples down like I have there, or you can just put my ones down, and that's the definition of a walk. So pretty much you're just going from one place to another. A trail is a walk but no repeated edges. So an example of something that's not a trail, let's say from G1 to P to F back to P. You see how I repeated the edge there? So that's not a trail. So G1 to P to F to P again. Since I've repeated that edge, that's not a trail, not trail, or not a trail. Let's use proper English here. And what else can we do? We can do W to T to G2. So that could be considered a trail. Yes, that can be considered a walk as well. So it just kind of overlaps. The trail has just the criteria where you cannot overlap an edge. Okay, and there it is, my rubber again. Then we go along. A path is a walk with no repeated edges and no repeated vertices. So in other words, you can't go back to the same place twice for a path. Okay. All right, let's try some examples here. So this question here is one walk is A, where's D? To D, to C, to F, to E, to B. All right, so does this walk represent a trail or a path? Let's see. Was any repeated edges? No, it can be considered a trail. Can it be considered a path? Yes, there was no repeated edges or repeated vertices. So this one could be, does this walk, it represents both trail and or a path. Because the definition, once again, is whether it has repeated edges or repeated vertices, and it's got neither of them. And my rubber does not want to work. Alright, let's try the next couple. Okay, then we've got circuit and cycle. A circuit is a walk that starts and ends at the same vertex and has no repeated edges. So a circuit could be here to here to here to here. You see, I start and end at the same vertex and I didn't repeat an edge. Okay. Let's see, what else can I do? I can go from here to here to here to here to here to there. That counts as a circuit as well. Now let's see if I can do one that repeats a vertex. That might be a bit harder. Oh no, let's try. Because if you've looked ahead, the cycle is a walk that starts and ends at the same vertex, no repeated edges, and no repeated vertices. In other words, a circuit can repeat the vertex. Here we go. Let's say P to Q to W, back to P to F to G2 to back to P. See how I hit P several times, but I never repeated an edge. So that one I just did could be a circuit, but that one cannot be a cycle because a cycle means no repeated edges and no repeated vertices. Okay, so that's the difference between those two there. All right, let's try this. So we're starting at F, going to E, to B, to C, to F. So that one is going to be a circuit and or a cycle because I haven't repeated any vertices and any edges, and I've gone from the start to the finish. And I think that's it. Well, I'm not going to rub it out. And that's it for 8D. So in 8D, it's just those 5 definitions: a walk, a trail, a path, and then a circle and a cycle. It's not too bad. Thank you.